Hello everyone. In this we will see our next problem, which is finding the peak element. This is a we in this problem we have to find the peak of peak. So let's go through the description. A peak element is a element that is strictly greater than its neighbors. So given an zero indexed integer array nums, find the peak element. Return its index. If the array contains multiple peaks, return the index to any of the peaks. So if there are many peaks, more than one peak, then we can return any uh, one of them. You may imagine that nums of -1 equal to nums of n equal to uh, minus infinity. So it says that in an array, like the left side of zeroth index and right side of last index value will be always we can assume as a minus infinity. In other words, an element is always considered to be strictly greater than the neighbor that is outside the array. So and also we have to we must write an algorithm that runs in log n time. So the problem when we see the when we first read this description, we can always come up with the solution with order of n. Order of n, like for example, this is our given example, and in this we can just iterate through the given array and find out each element left side and right side, which are smaller than the current element. That way we can find out the solution in order of n time. But in description it is asked for order of log n. So we will going to see how we can find out using log n time. Using order of n time, this problem is very easy, but log n time is little difficult. So let's see one. Let's also take this example. So here just we will see why we are getting here 5. So here if you see at index 5, is 6 0 1 2 3 4 5. So at index 5 we have element 6. So 6 left side is 5 and right side is 4, which is less than the 6. So that is the reason here our answer is 6 5, which is index of 6. And even 2 is also a greater than left and right element, so our answer also 2 also our answer. So let's take this second example and see the solution here. So if we assume this problem as a mountains, then it will be easy to understand this solution. So we can assume the given array as a given array elements as a mountain. So for example here we have 1 2 3 1 3 5 6 4. So we can assume 1, and from 1 to when we go to 2, the we will be going up, and when we come to 1 again we will be going coming down, and again when we go to 3 it will be going up. So we can assume something like mountain kind of thing. So here just I have drawn the this. So and also we this solution will not work in a case where uh, there are duplicate elements in the given array. So it is given that there are no duplicates elements in the given array, and also and also the edges will be always minus infinity. So the edges will be always minus infinity. That means these mountains always touch the ground, like always the uh, element element to left of index element at 0, like element at index 0, the left element always be less than this element, and the right side of this last element always be less than this rightmost element. So that is what it was given. And also the elements will be unique elements, and we can return any peak. So these are the conditions, these are the conditions for given. So without this condition this solution will not work. And let's see how it's going to work. So Initially I'll explain from this point. So these are the just edge case we are handling here, just edge cases. So I'll going to discuss this after discussing this solution. So here we can understand the logic by these two diagrams. So if we can assume this way, at every place we'll be finding out the mid. So this will work as a binary search, but a little different. So like binary search, we'll be finding out the mid, and then we'll be comparing the mid with left side and right side. Here we are comparing it with the left side, and here we are comparing with the right side element, and according to it we will be changing the start and end values. So we can assume this way. So here we have a let's assume we got it, this is our midpoint, and we'll be comparing left side. If left side is greater than mid, then our the peak will be left side of the array, this mid. So that is the reason what we will be doing is we'll be uh, in end we'll be storing mid minus 1. If if this is again mid, and mid is greater than the left side element, uh, mid is greater than the left side element, then definitely the peak will be right side, because uh, in question it is given that at the leftmost will be it will be my negative minus infinity. So if this mid is less than the this if mid is less than the its left element, and then this left element's left side somewhere we will face an element where which is less than this element. So the it's same for this as well. Like if mid element is greater than the left element, then at rightmost will be however touching ground. So then our peak will be something between this element, like mid to the last element. So that is the reason we will be going inside this else if condition, and we will be doing assigning start equal to mid plus 1. So while going through the solution, you will get to know about these elements. So initially we will assign start equal to so this is our given example. Initially we will assign take start equal to 0, and e will point to last index, and then this while condition will run till start is less than or equal to end, and in each iteration we'll be finding out mid. So initially we have start is 0 and end is 6, and mid equal to mid equal to here start plus end minus start by 2. So which is 0 plus 6 minus 0 by 2, which is 3. So here mid is 3, so now mid will point to 3, and we will be comparing here whether mid is greater than its left and right. If that is true, then we will be just going to return this mid, because that is the peak. Since here 3 is greater than 1, but 3 is not greater than right element. So that is the reason it will go inside this else if condition, and here it will again check whether mid is less than the left side element. This is not true, so again it will go into this else if condition, and it will here check whether this mid is greater less than the right side. This is true, so that is the reason this condition become true. So mid is greater this condition became true here. Like mid is here the let's assume this here, this is the rightmost element, like right element of mid, and this is the mid. Then right element is greater than mid. So right element is greater than mid, that means our peak will be right side. We can find our peak right side. So that is the reason now we will assign start equal to mid plus 1. So now start will start will point to index 4, and we will be searching in this. So we can find out peak in this left right side array. So now again start we have assigned as 4, so again we'll be finding out mid. 4 plus 6 minus 4 by 2, which is 5, and 5 will be comparing again 5 in value at 5. So here value at 5 is 6. 6 is less than greater than left side and right side element. This is true now. So this is our peak, so we will be just returning the peak. So that's how will be go this solution will work. And here we are writing this condition because this will one not work for edge cases. Like it will for example we can take this example. Initially again mid will point to 3, and we find out like above example, mid is greater than 1 but less than 5. So we'll start will point to again this, and again 5 is greater than 3 but greater than 3 but less than 6. So here we'll again point to 6. So like we'll repeat from here onwards so that it will not be a confusion. So we'll have we got 6 4 here 6, and when we use this formula we get here mid as 5, and we'll be checking the element at 5. 5 left side and right side are not less than 5, less than this. Since here 7 is greater than 6, so it will fail this condition, and this condition also fails because 6 is not less than 5. This condition becomes false because 6 is less than 7. So start will now point to this the last element. Now start and end will point to the last element. So in next iteration it this condition become true. So again here mid start will be 6. 6 plus 6 minus 6 is 0, so that is the reason we get here 6. But here we can't compare the right of the index 6, since array size is only 7. So the 6 is last index, so we can't compare with the right side. So that is the reason at that place it will give us an error saying index out of range. So that is the reason we are handling those two cases. Like this is the one case and this is the another case. So that is the reason we are handling those two cases here, where if n of if first element is greater than the second element, then in question it is said that the left of this element we can assume as a smallest of this element. So that is the reason we'll be just so in that case this value at index 0 will be maximum our peak. So we'll be returning just the 0 index 0. This is last element. If last element is greater than last but one element, then in that case last if here in this case if we can see 7 is greater than 6, in that case 7 is peak, because 7 right side will be however less than 7. So that is the reason we will be returning n minus 1. And also we are here handling if n equal to 1, then if n equal to 1, then there will be only one element in our array, and left side and right side will be always less than that one. So that is the reason we will be just returning that index 0. So we are handling those three cases uh, with these conditions, and this is how this solution will work. And uh, this solution will be very easy if we assume something this way. Like for if our array contains duplicate element, then this solution will not work, because here like here there we get a gap in mountain, and this condition like we can't move forward or backward. So that is the reason it will not work. uh, for example here itself, if you assume here 5, here 5, then at this place it will come initially compare 5 is greater than left side right side. This is false, so it will come inside this else condition. And this 5 is greater than here 5 is greater than 3, but 5 is not less than 6. So it will go inside this else condition. And even here we have 5 5, so even this will not go inside this else condition also. So that is the reason this loop run infinitely. So that is the reason even if we have duplicate elements, this solution will not work. And since we are each time we are only searching half of the array, so the and which is working like a binary search, this program will take order of log n time, and the space complexity is order of 1, because we are just using constant space here. And yeah, that's it for this video, and I'll share the solution and this image link in the description of this video. And thank you for watching.